This video will cover the Geometry Regents exam from January 2015, questions 5 through 10. Question 5 says, in the diagram below of rhombus ABCD, the diagonals AC and BD intersect at E. If AC is equal to 18 and BD equals 24, what is the length of one side of the rhombus, ABCD? So I'm going to take a second to just label. I have AC is 18 and BD is 24. Now we have to recognize the fact that we have a rhombus here because a rhombus has quite a few properties. A rhombus carries all of the properties of a parallelogram. So that includes that the opposite sides are congruent, opposite sides are parallel, opposite angles are congruent. Let's see, adjacent angles are supplementary, and the diagonals bisect each other. This property, the diagonals bisecting each other, is actually going to help us out here a little bit, because with those diagonals that bisect each other, we can split up this segment AC that's 18 into two pieces that are both 9. Same thing with the 24 can be split up into 12 and 12. Bisect means to cut in half, so they cut each other into equal pieces. Another property of a rhombus is that all sides are congruent. Not only are the opposite sides congruent, but every single side here is congruent. So that's why it says what is the length of one side of the rhombus. It doesn't matter which one we solve for. We're going to find the correct length no matter what. Another important property here is that the diagonals are perpendicular to each other, meaning that they form right angles. So then if we take a second to just focus on, say, triangle DEC, we have 12, 9, and a right angle, and then X, say for DC. We're trying to find out what that side length is. So because I know that the diagonals bisect each other, and because the diagonals are perpendicular, I can then solve for the missing side length. So here I'm going to use a formula called the Pythagorean Theorem. A squared plus B squared equals C squared. So I'm going to plug in A and B are always the legs right next to the right angle, and C is always the hypotenuse. So here we have 12 squared plus 9 squared equals X squared. 12 squared is 144 plus 9 squared is 81 equals X squared. So then we sum those together to get 225 equal to X squared. In order to solve for X, we have to square root both sides. So now X is equal to 15, meaning that one side of the rhombus is 15, choice 1. Number 6 says, what are the truth values of the statement, opposite angles of a trapezoid are always congruent, and its negation? So first we have to determine the truth value, whether it's true or false, for the original statement, opposite angles of a trapezoid are always congruent. Just to remind you, a trapezoid is a figure that looks like this, where opposite sides are parallel. Unfortunately, we know nothing about opposite angles such as this one here and this one here. And so the truth value of the original, the statement, because we know nothing about those opposite angles, whether they're congruent or not, the truth value is false. So then the negation is where we insert the word not. Opposite angles of a trapezoid are not always congruent. If the original statement was false, then the negation must be true. So I'm looking for a statement is false, negation is true, choice 3. Number 7 says, what is the length of a line segment whose endpoints have coordinates 5, 3, and 1, 6? In order to find length, what we're going to do is make a table here, where we find the change in X, the change in Y, and we use the Pythagorean Theorem. Now change that triangle means to subtract. So we're subtracting x values, we're subtracting y values, and then plugging them into the Pythagorean theorem. So first I take my x value is 5 and subtract away 1. If it helps you to label these as x1, y1, x2, y2, then please by all means do so. And for my y values, I have to be consistent. I'm going to start with y1 since I originally started with x1 for the change in x. So we have 3 minus 6 here. 5 minus 1 is 4. 3 minus 6 is negative 3. When we plug into Pythagorean theorem, ignore the negative. Okay, we don't need negatives because if you square a negative number, it turns positive anyways. So now I'm going to plug in 4 for A, positive 3 for B, again ignoring the negatives, and my goal is to solve for C. So here we have 4 squared plus 3 squared equals C squared. 4 squared is 16 plus 3 squared is 9 equals C squared. This means that 25 is equal to C squared. Do not get tripped up here. 2 is not your choice. We still need to solve for C, so we need to square root both sides, leaving me with a final answer of C equals 5, or the length. Remember, Pythagorean theorem helps us find length. The length is equal to 5. Choice 1. So answers for this page, we have number 5 is 1, 6 is 3, 7 is 1. Number 8 says, in the diagram below of isosceles triangle ABC, the measure of the vertex angle B is 80. If AC extends to point D, what is the measure of angle BCD? So what I'm going to do is choose to call this X. I'm going to find it on my picture BCD and also call that X. And in order to find that angle, I have to first find angle A and angle C. Well, angle BCA rather. And notice that it says that this triangle is isosceles, which means that there are 2 congruent sides. Those 2 congruent sides were already marked up on the picture. And because there's 2 congruent sides, there's also 2 congruent angles. That's where I came in and marked my 2 congruent angles. So I'm going to take a second to find them. I'll choose to call them both y. They're both the same because they're congruent. So I have y plus 80 equals 180 because 3 angles in a triangle sum to 180. So now we have 2y plus 80 equals 180. Subtract the 80 and we get 2y equals 100. So then y equals 50. That means each of these angles are both 50 degrees. My next step is to find this exterior angle, BCD. In order to do so, I have one of 2 options. I can look at this picture and say, okay, we've got 2 angles on a straight line. Of course, those sum up to 180 degrees. 50 plus x equals 180. So then x equals 130. Choice 4. Or the second option is to use something called the exterior angle theorem. Again, it's called the exterior angle theorem. You still have to go through this first step, but your second step of finding this exterior angle is to take the 2 inside numbers, inside plus inside, and set it equal to the outside. Now it's the non-adjacent inside angles, meaning the ones that are not touching the outside. So I have 50 plus 80 equals x, which again, of course, sums to 130. So same answer, choice 4. Number 9 says a student used a compass and a straight edge to construct CE in triangle ABC as shown below. Which statement must always be true for this construction? Now, if you can recognize this construction as 1 smiley arc, 2 baby arcs, and the line passing through, you would immediately know that this is the construction of an angle bisector. Meaning that the 2 baby angles right here are congruent to each other. Angle ACE is congruent to angle BCE, giving us choice 2. But if I didn't know that, or if you didn't know that right away, then we could look through these options and try and figure out which one's true. The first option says angle CEA, right here, is congruent to angle CEB. right here. This is clearly not true. One of them is slightly bigger than the other. I know it's tough to see, but it's not true. And the next one, that's our choice, angle ACE is congruent to angle BCE. You can see that these two angles are congruent to one another, unlike in number 1. Choice 3 says AE is congruent to BE. AE is slightly smaller than BE, so this is not true. And choice 4 says EC, this segment here, is supposed to be congruent to AC, which again is not true because EC is slightly longer. So our final answer again should be choice 2. Number 10 says in triangle ABC, the length of AB is 4, BC is 7, and AC is 10. Which statement is true? So what I'm going to do here is just sketch this triangle, ABC. It doesn't matter what kind of triangle you draw. A, B, C. AB is 4, BC is 7, and AC is 10. This is taking us back to the fact that the opposite angles are related to sides. And by this I mean that the largest angle is opposite the largest side. So what we're going to do is kind of make a list going from, say, smallest to largest. Side AC is the largest side, which means that angle B opposite it is the largest angle. So I'm going to put an L here for large, and I'm going to put angle B up here. Angle C is opposite of the shortest side, which is a 4. So this means that angle C is the smallest angle. 7 is the medium side, which means angle A is the medium-sized angle. Angle A. And now what we need to do here is put in some inequality symbols. Angle C is smaller than angle A, or less than angle A. Angle A is less than angle B, because remember, B was the largest. But unfortunately, when I look at my choices, when they go in the order of C, A, and B, like choice 4, the inequality symbols are in the wrong direction. It's telling me that angle C is greater than angle A, which is greater than angle B. But this is not true. Remember, we said B is the largest. So what I need to do is just kind of look at this backwards. Angle B is greater than angle A, which is greater than angle C. Choice 2. So our answers for this page are the following. Number 8 is choice 4. Number 9 is choice 2. And number 10 is choice 2.